So now that we have information, we measured it, we have it somewhere, it's stored, it looks really good. Now we have to make that information relevant to people we're talking to. So usually we get some sort of reports out of these systems. And people usually make one report that's very complex that nobody uses. You have to usually make two different reports. I always suggest making two reports, one for management, one for shop floor people. Because they don't want to see the same information. Shop floor people need much more detail in what they get. Management wants to see a bird's eye view. They're not interested in any knob out there. They want to know how we're tracking versus what we promised. The shop floor guy wants to know which button I have to push to make it better. So you have to tailor these reports to people that you're sending it to. And the second thing is, make those reports very simple. I used to have, in a facility where we track the production, we used to have crystal reports. Those went on 3 pages. I looked at the first page, I threw it into the waste basket. It didn't tell me anything. I would rather go down to the operator and ask him how he's going today. Well, that's not the point of the report. You want a report, you want to have a glance at it and say, oh, I'm doing well today. Forget it. Or, wow, something's going on that I need to get down and find out. You have to make these reports pop up and stand out. Don't be afraid to use primary colors. We're all kids at heart. Red, yellow, green. Use colors that make sense. Don't use like drab gray. And make it intuitive. So what do I mean by that? You have to have pretty much 4 different cases that's going on. Performance today is bad, but we expected it. For whatever reason, we make many changeovers, we had problems with the equipment overnight. Whatever the reason is, we know we expect bad performance. So that's okay, it's bad, but we know why it's bad. The second one is, oh, we're doing good today, but we have no idea why. We made today 20% better result than ever before. Did anybody change anything? No, 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 no. You want to know that. This is important information, as important as the bad information. This one we all know. Performance is bad, we don't know why. Nobody touched it, nobody went by it. It doesn't work. We want to know that. And of course, this one where performance is good, we do know why, we expected it, this is our usual standard. So those are 4 possible cases. For each one of you, when you design energy management system, come up with something similar. It doesn't have to be the same, it doesn't have to have same color scheme, doesn't have to have the same wording, but come up with the same ideas, because these 4 things make 4 distinct decisions on your part, how you're going to proceed. They're not the same. They cannot be treated the same. Let's look at this. If you show this to the operator, and he looks at this data coming up day in, day out, what happens? Tunes it out completely. Yet another data point. It looks just like the data point yesterday. Yeah, one is up, one is down, but you know what? They look the same. What about now? You say, oh, this became red. And he's got in his standard operating procedures, if it's red, call Ed in the office up there, tell him something's red. Now he's got something to act upon. It's yellow, it's blue. We said red and blue are bad, yellow is okay. At least we understand it. The other 2 we don't understand. Wouldn't it be nice if that system, when this happened, sent you an email automatically? These are computers, this is data. This is electronic signals. You can make electronic signal today, do whatever you want. So if this is the data point you didn't expect, and it's bad, this data point can trigger the email system to send you an email on your BlackBerry, on your iPhone, on your desktop, whatever works for you. Now you know when something happens immediately. How many of us have sat in the meeting 3 weeks after it happened and said, ooh, we had 3 weeks ago, we had a really bad instance of something. Who was on the shift? Who knows about it? Who will tell us what happened? How many of those actually resulted in actionable items? Probably none. But if you get information right now, something's going on bad, how many of us can go down on the floor and say, let's find out what's going on now? That's what electronics is. That's what energy management is for. And of course, the follow-up question to this, how the hell will I know when it's good, when it's bad, right? What's good, what's bad? Joe tells me it's bad now. Ed tells me it's bad today. I don't know. We have to find out how. How will we know that? What makes good or bad performance for our case? You have to have understanding what's normal for your particular operation. You're the experts in it. You live it day in, day out. You know what's normal. So you have to define it. Of course, guessing at it doesn't work. So we need a baseline. Not that baseline, the other baseline. We need a baseline. And what is a baseline? It means that we're collecting data over a specific period of time, historical period of time, with a specific purpose of finding out what our regular performance is. Right? So we have to, when we do this, we can't say, well, we'll just measure something for 3 days and we'll call it a baseline. If you're measuring something that's never changing, that is day in, day out, 365 days a year, always the same, fine, 3 days is more than enough. But let's say you're trying to find out some seasonal averages. Well, then your energy driver is seasonal, it's temperature. So you have to go through the whole process, through the whole entire range of one season to be able to justify what is the seasonal impact. So I can't tell you what the baseline period should be because it depends on each energy driver separately. But you have to let it go through the entire range for it to be meaningful. And then you do data analysis on this baseline to establish those expected values. This is the heart of the baselining. That's what you do. That's how you then know this is the data we can achieve historically. This is what we should consider our normal performance. Unless you had a really bad year all year, then all bets off. But typically this is how it happens. But it truly, that's what it is. You're shooting for something. You aim to get to that level, whatever that level is. That's all it is. By very nature, targets are very subjective. Plant manager will probably want to have really high targets. The guy on the floor really want to have low targets. So they're subjective. So you have to come up with some sort of way of fairly assessing the targets, especially when you start energy management. If you're in it for years and years and years, people know the drill, they expect it. If you're starting up, start with the reasonable targets. Usually there's a question, do you want to benchmark against your competitors? Do you want to benchmark against your historical consumption? What is it that you want to do? Right? And my personal suggestion is, whatever you do, make them smart. Specific, measurable, achievable, realistic, and time-bound. Okay? And rebase it every year. So my personal advice to customers that ask for that, I always say, take your historical performance as a starting point. You know you can reach it. You're not going to make anybody totally disengaged because your target is so much higher than they're like, I'll never reach that, forget it. So start with your historical best. Then build from there. Specific targets, don't use reduced by a lot because that doesn't mean anything to anybody. Use numbers, 3% or X gigajoules. Use specific numbers. They must be measurable. You installed all these systems. You have fancy data collection. So don't make your target something that needs to be divided by 3 different factors. Make it something that's visible on the screen for everybody. That way they can relate it. They can say, I know what my target is. I can see where I'm today. It buys you an engagement. They have to be achievable. We already talked about it. If you yourself get a goal at your yearly performance review from your bosses that's unachievable and you know it's unachievable, what do? I'll just go through the year. I don't care. So it has to be able to stretch you a little bit, but not stretch you so much that you're disengaged. They have to be realistic. That's why I suggest using your own historical performance rather than best practices. Best practices are very good intention, but if you don't know exactly what they use best practices to gauge on, you're really swimming blindly. And I don't recommend that. And they have to be time-bound. So if you say, I want to reduce 10 gigajoules, 10 gigajoules per hour, 10 gigajoules per year, 10 gigajoules for the next 10 years. Based on what? Because that gives people a frame of mind that frames it what their goals are in very specific terms. This is same as what we had before, months over 3 years, natural gas consumptions on a monthly basis, outdoor temperature, and I added production data in there. Because usually in industrial environment, without putting production data there, you're really not doing energy assessment, no energy analysis. Because production is what drives your energy costs and the reason why you use energy in the first place. So if I told you, you use this much per month and you produce that much, and I give you a graph like this, would this mean anything to you? Would this be actionable item? Probably not. It looks kind of funny, but what the hell? So we need a model. We need something to connect these dots for us and tell us what these dots actually mean. That's what the models are for. To read it out of the, it's a mathematical model, gives us a way to predict something. So you take a set of inputs. In our case, usually it's weather, production, and building stock. You put it in the black box that we call a mathematical model, and out comes energy consumed that we predict you're going to consume. That's what the energy modeling is. It's very simple. So I'm going to go through a brief run of statistical models. I'm not a statistician. I don't pretend to be. This is not a statistical course. It will give you an overview of what it is. There are other statistical courses available. But for your particular data, if you're interested in ever looking at your data, our ESCs can work with you on a first cut to show you what type of things we have to look for to do simple linear regression, to show you how to get started. And then you can build from there. So don't mistake this for a statistical course. You won't come out of this course and say, oh, now I know how to do regression left, right, and center. You won't. But you'll have appreciation for what needs to go in. So energy model in particular, energy management model, if we're trying to predict energy consumption based on the given set of inputs. Well, if you look at it mathematically, it means we have one numeric dependent variable, which is our energy, and we have one or more numerical or categorical variables that go in there, independent variables, which is what we call energy drivers. So we have energy and energy drivers. Now, if you remember math calls that regression model. That's why we use regression models in energy management. Because we have a number of variables, independent ones, and we have one dependent variable coming out of it. This is just an example of what some linear regression will look like. For example, this is natural gas usage per month on this side, and down on the bottom again, temperature. This is what the model would tell us. This black line in the middle is the model's interpretation of how the energy relates to the outdoor temperature. You get the formula, you get R square, everybody's happy. This is pretty good. R square is 0.88. The data seems to be clustered around the straight line, so we seem to be okay. So linear regression, good. But let's look at the other linear regression sample. This is also linear regression. It's also as valid as any other one. But now your R square is 0.02, and it's obvious, forget R square, forget the mathematical examples, it's obvious that the straight line is far away from your usual data points. So you intuitively know that this does not properly explain my energy usage. And that's how you should really look at linear regression results. Don't focus on R squared, don't focus on the numbers, focus on what it looks like. You can tell that this one looks much better than this one. But they're both equally as valid. So you need to understand, you need to interpret the data. So the way to interpret this data is to say, my energy consumption seems to be far more reliant on outdoor temperature than it does on production levels. So some people might think, oh, this must be just heating and ventilation. Somebody only uses the energy for heating and ventilation. Well, this is the paint line, guys. Paint line. Most of the energy in the paint line is dependent on the seasonal temperature outdoors, not on your throughput. You use almost as much energy regardless how much throughput you put through. So that tells you, I better load that paint line as much as I can and run it for all it's worth and then take 2 days off, rather than run it for 5 days, 3 hours every day. Because the losses out of this paint line are horrendous. And this is not a bad paint line. This is regular paint line. This is nothing special. So that's how you have to interpret energy management. What is this information telling me for my process? I know my process. Mathematics just helps me put it into perspective.